Let's have a look on our sixth question now. So what we have to do over here is we have to run ridge regression using standardized predictors. So to do this, what we will have to do is we will have to use leave one out cross validation and shrinkage parameter from 1 to 200 along with step size equals 10. And at last what we have to do is we have to report RMSE. So starting with the code, what we are doing over here is firstly, this line creates an instance of ridge CV regression model M2 from scikit-learn. It performs ridge regression with cross validation to select the best shrinkage parameter from a specified range A over here. The alphas parameter is set to A and store CV values is set to true to store the cross-validated predicted values for each alpha. The model is fitted using standardized predictors x underscore std and target variable y. Later on over here, what we are doing is we are just calculating the mean squared error MSE of the best performing model from cross validation by retrieving the negative of the best score from M2 and assigning it to MSE2. And to view the value of MSE2, we have written this code over here. And as we can see, we have got the output of MSE2 over here. Later on, to check the shape of the M2.cv values, we are using dot shape over here. And as we can see, this is the shape of M2.cv underscore values. And later on, over here, what's happening is it retrieves the shape of the cross-validated predicted values stored in m2.cv underscore values underscore. At last, what we are doing over here is we are calculating the root mean squared error RMSE by taking the square root of MSE2. So RMSE2 outputs the value of RMSE2 as you can see over here. So this is how we have completed our task for this question. Let's move on to our next question now. What do we have to do over here? Run the lasso regression using standardized predictors. We have to use five-fold cross-validation over here, and later on, at last, we have to report RMSE for the best model. So, firstly, what we'll do is over here we will start an instance of lasso CV regression model M3. After creating it, it performs lasso regression with iterative fitting over here along a regularization path. The model automatically determines the optimal alpha by using cross validation. The model is fitted using standardized predictors x underscore std and target variable y. So the default number of alphas over here is set to 100 as we can see, and default number of folds for cross validation is 5. So moving on to our next code, what we are doing over here is we are trying to find the shape of m3.alphas. So this indicates the number of alphas available in the regularization path, and displayed alphas provide a subset of the values used in fitting the model. And for fitting first 20 alphas, we are using this code over here, which retrieves and prints the first 20 alpha values from the alphas underscore. And later on, to get optimal value of penalization chosen by cross validation, we have written this code over here. So what value we are getting over here is we have retrieved the optimal value of penalization parameter alpha chosen by cross validation. It represents the best alpha selected by the lasso CV model. In the next part of code over here, we are trying to print the shape of MSC path, which is attribute of M3. And this over here, this line is retrieving and printing the mean squared error values from MSC path attribute of M3 for first 5 cross validation folds and all alpha values. Now to find the index of optimal alpha, we are trying to assign the array of alpha values from lasso CV model M3 to variable ALP, and we are trying to convert it to list using dot to list function, and it is used to convert array ALP to list. So this array ALP will be converted to list using this function, and let's check the length of the ALP underscore list. So we are using length function over here, and we got length as our value of 100. So to get the best index over here, what we are trying to do is we are trying to use dot index function, and we are passing m3 dot alpha value over here to it. So using that, we are getting best index, and we have assigned that value to this attribute over here. So this is how we have got best index. Now what we have to do is we have to retrieve mean squared error value. So we wrote this code over here, and we are passing best index to it. So this is how we have retrieved mean squared error value from the MSC underscore path attribute of the lasso CV model M3 at the index best index. Uh, and we have got the value over here in the form of array list. And at last, we are trying to calculate root mean squared error. So what we have to do is firstly we have to take mean of this attribute, and later on we have to perform square root on it to get root mean squared error RMSE for dataset. And this line of code displays the calculated value of RMSE over here. We have got one optional exercise over here where what we have to do is we have to count the number of non-zero coefficients from the lasso regression. So here information regarding few data types is given. This is basic of Python code. So what they are trying to explain is list and tuple are ordered collection of data, but we can change a list or values of list, but tuple is unchanged. This is really important and really basic. So we will be using this thing in our code later on. So let's understand the purpose of the code over here. So firstly, what we are doing over here is we are trying to print the length of this attribute over here, which represents the coefficient obtained from lasso CV model M3. It indicates total number of coefficients in the model. Additionally, it displays the first 20 coefficients from M3 coefficient attribute. Later on in the next lines of code over here, these lines print the length of the M3 coefficient dot non-zero. So non-zero function is used over here. So it will display the indices of non-zero elements in the coefficients. So this attribute function returns a tuple of arrays where each array contains the indices of non-zero elements. The length represents the number of arrays in the tuple, which indicates the number of non-zero coefficients. In this case, we have 58 indices combined as one. So we can see 58 indices are combined as one element. Over here, what we are trying to do is these lines print the type of M3 dot coefficient attribute and the type of M3 dot coefficient dot non-zero function result. It shows that M3 dot coefficient is the type numpy dot n dimensional array, as you can see over here, and the type of our non-zero function would be tuple. Let's look at the length of uh, this M3 dot coefficient dot non-zero function at zeroth index. So this line retrieves the length of the first element of the M3 dot coefficient dot non-zero tuple. So first element, because we are using zeroth index over here, it represents the number of non-zero coefficients in the model. And we have got 24 as our number. So we can see that first dimension of the tuple has 24 elements. And at last, let's see how many non-zero elements are there from total coefficients. So for that, we are trying to write over here a print statement, and we are appending the values of length of m3 dot coefficient attribute and our non-zero function with first index. So out of 2 and 5 coefficients, we have got 24 as our non-zero elements.